Simran, in improve phase, we didn't discuss about the cost benefit analysis. Last day you said that you will cover that today.
Yeah, so cost benefit analysis is, as I said, that I'll be sharing some formats. Cost benefit
Okay.
analysis is the one we discussed that is used to calculate the dollar benefit, the pound benefit,
Mm-hmm.
or the rupee benefit for any project. It depends upon the organization to organization that how they are calculating it. Some organization take finance approvals also. Some organization take the head of the department approval, the CEO approval also. So there are different formats which are used for CBA calculations for even during the project or outside the project. But I have some formats for different metrics which I'll be sharing it. Okay, wherein you'll
Sure.
be able to understand. So there is nothing that we need to know about it. It is only calculating the benefit, the tangible benefit for the project.
Okay.
Okay, so these formats which I'll be sharing are very simple and easy to understand. You just have to put the numbers, and there are certain logic which are being given. With the help of that, we'll be able to calculate that how much is the benefit. But it depends upon the organization to organization. That sometimes it has the FT cost. Okay, so we don't know what is the FT cost of that organization. Okay,
Right.
and there's certain permutation and combination logics that are being given to calculate that benefit, but I will show you some of them wherein you'll be able
Sure.
to see it. Okay, so now we have come to the last phase of the Six Sigma, which is the control phase, which means that we have done till the improve, wherein we have improved the current state, move from the existing problem that we had, and we have already implemented all the solutions. We have done the FMEA, we have done the design of experiment if was required, and now we have already achieved what we wanted to, but we can't close the project here because we want to ensure that the solutions are sustained or not. So therefore, for 2 to 3 months we are going to be in the control phase, wherein we'll be using some tools and techniques like control charts to measure the process performance and to come up with a conclusion whether my process is control or not. So that's what I will be doing in the control phase. I'll be also preparing a control plan, the handover plan, which I'll be giving into the management, wherein I would declare that this process now becomes a business as usual, because we have already shown a sustenance of 2 to 3 months. We have also come up with the control plan, and this is something which needs to be implemented. So that is the end result of the control phase. So, as I said, sustained improvement once the new solution is implemented. This is also referred to as holding the gains. It proactively monitors the process on an ongoing basis, and it transitions from project to process. Okay. So this is just information about the control charts. Dr. Walter Andrew Showart in the year 1920 come up with a concept that control chart is something which we should prepare, and this basically talks about the upper and lower control limit. So we'll talk about what is upper control limit and lower control limit. Earlier we discussed the upper specification limit and lower specification limit. Do we remember that? What is USL and what is LSL?
Yeah.
Yes.
Okay. So who defined the specification limit?
The stakeholder.
Customers.
The customer, the stakeholder. Okay, so that is the specification limit. However, there is a control limit also. So instead of UCL or LCL, I said UCL and LCL. Okay, so USL or LSL, I said UCL or LCL, which is called lower control limit and upper control limit. So these limits are not defined by any customer or any stakeholder. These are data driven. Basis the data that we have, on which we are monitoring the performance, my visual representation, my UCL and LCL, my upper control limit and lower control limit, will be populated by the data itself. Okay, so Minitab or any statistical tool on which I'm running the control chart would give me a upper control limit and lower control limit. And on basis the lower control limit and upper control limit, I will be able to make a decision whether my process is in control limit or outside the control limit. If it's within the control limit, which means I would say my process is in control. If it's outside the control limit, which means my process is not within control. And which is not within control, which means it has a lot of variation, which I will not be able to forecast in the future. So I will, let's cover it one by one. One is a common cause, which we discussed in the measure phase also, which is inherent to the process or random, and it is not not controllable if only common cause present. This is within control. And special cause or assignable cause is when the process is out of control, when there is a variation due to the outside influences. This is something which we are already aware of. Similarly, when we talk about the control limits, the UCL and LCL, okay, if the data is outside the control limits, I will show you the Minitab representation as well. If my data is outside the control limit, either the lower control limit or the upper control limit, during the control phase, if my data is outside the control limit, either on the lower side or on the upper side, I would conclude it that there is a special cause variation which is there in my data, due to which I would conclude that my process is not within control. There is a special cause, I need to remove it. Then only I'll be able to go ahead. Okay, so that's what is the special cause, that's what is the control limit. So now let's see the difference between the control limit and the specification limit. Specification limit are defined by the customer. However, the control limits are derived by the data itself. So interestingly, it is not being communicated by anyone, control limits. The data decides on its own. The type of data, the number of sample points, the number of measurements, everything into consideration. The data itself calculate the lower control limit and upper control limit and gives you whether you can conclude, whether you can continue further to say that your process is within control, or say when your process is outside your control. So that's what my data tells me. Okay. Now let's get into the control charts, because control charts are the only charts which would tell me all these things, which would tell me whether my data is within my control limits or not. And this would also tell me whether I need to proceed further or not. So there are 7 types of control charts that we have. We don't have to use all of them together. It depends upon the data that we have, on which basis which we decide which control chart we are going to use. Sometimes we can use more than one also, basically the different combinations that we have. But yes, let's first understand that in which scenario we will use what sort of a control chart. Okay. So if my data is variable, which means if my data is continuous, okay, I will use 3 sort of control charts. First is the IMR chart, which is called the individual moving range chart, when my subgroup size is 1. Okay, here the subgroup is not what we discussed earlier. It is not the levels. It is not the subgroup. This is a different meaning of subgroup here, which I will explain later. If my subgroup size is 1 and if my data is continuous in nature and I've reached the control phase and I want to know whether my current performance is within the control limit or not, I will use an IMR. If my subgroup size is 2 to 5, then I will use an X bar R chart. R referred to as range here. Okay. Do we know the formula of range? Just check.
Max minus minimum.
Yes, so I'm checking the range here with the help of X bar R. If my subgroup size is between 5 to 9, then I use X bar S, and S stands for standard deviation here. Okay, so
And what was the IMR full form, Simranpreet?
Individual moving range.
Okay.
Yes, so we will cover that once we do the Minitab hands-on. If my data is discrete in nature, okay, then there are 2 combinations. Either my customer is measuring me on defective, else my customer is measuring me on defect. Do we know the difference between defect and defective? We discussed during DPU session in the measure phase.
Product and defective means number of products.
So one product can have multiple defects also.
Yes, one product can have multiple defects.
So when my customer is measuring me on defective, which means either pass or fail, if he's like, if I have hand over the services to the customer and if he has liked it, so you got a packet from Amazon, you liked it, you say yes. If you didn't like it, you call it as a defective. Okay. However, you find there are some defects which you can still be okay with. That's a defect. So defective is pass fail, and defect can have multiple opportunities. So we covered this.
Defective can be a binomial distribution, right?
Yes, defective can be binomial, either pass or fail, yes or no. And defect can be have multiple. So if my data is discrete, and if I'm defective, then again I have two variants: constant and non-constant.
If binomial or is it binary?
The binary, yes or no, pass or fail. Okay. If I'm measuring it on defective or defect, I have two variants. One is constant and another is non-constant. So if my volume, if my performance, if my total data points that which I am measuring is constant during the during month, weeks on which basis that I have the data, it is then in that case I'll use an NP chart. If the volume varies on a daily basis or on a weekly basis, or depending upon the data that I am plotting, then I would consider as a non-constant. So for constant defective, I use an NP chart. For non-constant defective, I use a P chart. And in case of a defect, if my volume is constant throughout the month, I use a C chart. If it's non-constant, I will use a U chart. Okay. So these control charts are always prepared on a time series plot, wherein you have a data as per the date. You would have a data as per the timings also. Okay. Maybe your data have for daily basis, monthly basis. So you should have on a series wherein you have the time or the date captured, like for January, February, March, April, or could be days of the week, or could be Sunday, Monday, Tuesday, or it could be first, second, third. So it should be on a over a period of time. So that's how we would have the control chart for. Okay. So these are the 7 control charts that we usually prepare or work on to look whether if there is any special cause variation in my data. So let's do this. Let's do this some examples on Minitab and see that whether I have control, whether my data is control or not. Okay. So